Hello students, I hope you are clear with the theory on force and pressure. Just in case any concept is not yet clear, please go back to that part of the video and get your concepts clear. Then you can pause the video and solve and spend around 10 to 15 minutes in solving textual questions. Then you can resume your video and see the solutions of the textual question. Let's begin with the textual questions. Let's see the first type of questions. Fill in the blanks. Here, the first question is, if the spring balance graded in gravitational unit, what is gravitational unit? GF or KGF, right? CGS system, so it is GF. Shows 20, that means the reading is showing 20 GF, 20 gravitational force. So the mass of the body is nothing but 20 grams, right? The mass of the body is 20 grams. Okay. Then the mass of the body is dash kg. Convert this into kg. How do you do that? You divide it by 1000. So you have 20 divided by 1000. You get 0.02 kg. Clear? So the answer is 0.02. Let's see the next question. The direction of the motion of a tree appears to be when a passenger observes it from a moving train. A passenger sitting in a moving train. Imagine that you're sitting in a moving train and you're observing a tree. So what happens? If your motion is in this direction, you feel the tree is going behind. So it will depend on the motion of the train, and in which direction will the tree appear to move? In the opposite direction. Opposite to the direction of motion of train, right? Direction of motion of train. So the answer is the tree will appear to move in the opposite direction to the motion of the train. Let's see the next question. Maglev trains work based on dash. On what principle do they work? They work on electromagnetic induction, right? They work on the principle of electromagnetic induction. Clear? Okay. Let's see the next question. Contact force acting on a dropped body is, now imagine a body is dropping down, right? So it's dropping down. It has been pulled by this earth, right? So that is a non-contact force. So what is the contact force acting on a drop body? 0, right? But when the body is coming down, air is going to apply friction, right? And that is going to be a contact force. So I'll say contact force acting on a drop body is frictional force applied by air. Okay, so it is 0 in case of, like, when I consider the earth and the moving body, but there is a frictional force applied by this air. Hence I say contact force acting on a drop body is the frictional force applied by the air. Clear? Let's see the next question. 1 Newton is the weight acting on a mass of dash. So the weight is 1 Newton. What is the formula for weight? Weight is equal to mass into acceleration due to gravity. And the weight is given as 1 Newton. So I'll get this as 1 is equal to m into acceleration due to gravity. For calculating purpose, I'll take it as 10. Right? So what is the mass? Mass is nothing but 1 by 10. Right? 1 by 10. So that is, so the mass is 0.1 kg. Right? Why? Because I've taken all these in MKS system or SI system. Right? I have used SI system. So my mass is 0.1 kg. So answer is 0.1 kg. Clear? Let's see the next question. Let's see the next kind of question. It says select the correct alternative from the given choices. That means 4 choices will be given to you. That means it's a multiple choice kind of a question. So 4 choices will be given to you. You have to correct the correct alternative. Clear? Let us see the first question here. Which of the following acts on a body from a very far distance? And we all know the far distance forces are gravitational force. Let us see if it is there. Electric force, no. Magnetic force, no. Frictional force is a contact force. So gravitational force is the right answer. Clear? Let's see the next question. Which of this is not a unit of force? Force is nothing but mass into acceleration. Right? Okay, let us see. Kilogram force, yes, it is a unit of force. Newton, it is a unit of force. Gram weight is a unit of force. So all these are units of forces, right? None of this, yes. So this is the right answer. So my correct alternative would be, which of this is not a unit of force? None of them. All these are units of forces. Clear? Let's see the next question. Electric force exists between, now electric force will exist between charges, right? They'll exist between charges. 2 masses, no, they have to be charged. 2 magnets, no, again the charge should be there. 2 electrons, electrons are negatively charged, so yes, it will act on that. 2 bodies, no, so it will act on 2 electrons since both of them are charged bodies. So electric force will exist between 2 electrons. Okay, let's see the next question. Choose an example from the following where action and reaction pair exists. So action and reaction both should occur. So a book placed on a table. This is a table and you have placed your book on this. So book will exert this force and the table will exert this force. So action and reaction force do exist here. So that's the right answer. Next, so action and reaction force do occur here. A person walking on the road, when you're walking on the road, you're pushing the road behind, road is pushing you, yes, there is an action and reaction force. 1 kg mass suspended from a spring balance, right? This is a spring balance, the mass is pulling it down and the spring tension would be pulling it up. So yes, there is an action reaction force. So in all these cases, there is an action. Last one, all of the above. So the answer is all of the above. So action and reaction force is occurring in all of these given conditions. Let's see the next question. Choose the incorrect one from the following. So you have to select the incorrect one. Let's see the first one. Electric forces can be attractive or repulsive. That's right. If there is a like and unlike charges, they'll attract each other. If there is a plus or minus charge, they'll attract each other. If there is a charge and uncharged body, they'll attract each other. If there are 2 like charges, they'll repel. So that means there is attraction as well as repulsion, right? That is right. Gravitational forces are attractive in nature. Absolutely right. They are attractive in nature and they are long range forces. This is also right. So first 2 statements are correct, right? We want to find the incorrect one. Next one. Magnetic forces cannot exist with a single magnetic pole. Now, for example, if you have a single magnetic pole in use, right? You're just using the north pole. Is the north pole proper? Let me draw the north pole properly. You're using a single north pole and you have some iron filings here, right? Will they attract? Yes or no? Will they attract? Definitely they'll attract. That means with a single pole also force of magnetic force would be there. So this is incorrect one, cannot exist. So that is incorrect. So this is my right answer. But just let me see the fourth one too to be absolutely clear. The energy of the flowing water is used to produce the necessary force which runs a generator to produce electrical energy. That's absolutely right. That is what happens at hydropower station. That means the water is flowing through the pipes, falls on the generator, I mean the turbine, and the turbine rotates. This will rotate the coil inside the generator, and that is how electrical energy is generated. So the last statement is absolutely right. This is what is written is the main working of hydropower station. So the incorrect answer is magnetic lines of forces cannot exist with a single magnetic pole. That's a wrong statement. Okay, let us see the next one. Let's begin with some understanding based questions. Let us see the first question. Define gravitational unit of force and relate them. So you'll have to first define gravitational unit of force. Now, for this, understand this. Suppose this is an area where standard gravitational field is acting. So this is nothing but standard gravitational field, right? This is a standard gravitational field. Just in case I have a body here of 1 gram. The mass is 1 gram. Okay. So the mass of the body is 1 g, 1 gram. The force would act on this because it is in the standard gravitational field. The force on a body of mass 1 gram is called as 1 gram force. So what is the unit of gravitational force in CGS system? That is 1 gf. Clear? Okay. So just in case if I have a body of 1 kg, 1 kg will be called as 1 kgf, right? And how will I define that? A force equal to the force on a body of mass 1 kg in a standard gravitational field. Clear? So I have defined both the units of both the gravitational unit of force. Clear? 1 gram force as well as 1 kilogram force, and then relate them. I want to relate them. Now it is quite simple to relate them. Now look at this 1 gram force. How would you convert grams into kilograms? 10 raised to minus 3, right? Multiplying by 10 raised to minus 3. So it will be minus 10 raised to minus 3 kgf, kilogram force. Clear? You're not supposed to write a dot here, right? So 1 gf is equal to 10 raised to minus 3 kgf. Clear? Now let us go the hard way round. For this, what will I do is, I'll explain you what is 1 gf equal to in CGS system. The CGS unit of force is dyne. So how do I convert 1 gf into dyne? For that, I'll have to multiply acceleration due to gravity in CGS system. And acceleration due to gravity in CGS system is 980 centimeter per second square. So if I multiply 1 to this, I'll get the answer in dyne. So 1 gf is nothing but 980 dyne. Clear? Now let us convert this dyne. Let me take some other color for this. I'll convert this dyne into Newton. And how do I do that? I know 1 Newton is equal to 10 raised to 5 dyne. That we have already learned, right? 10 raised to 5 dyne. Now, so 1 dyne would be 10 raised to minus 5, right? So if I multiply this 980 by 10 raised to minus 5, my answer would be in Newton. Is it clear? Now, if I put a decimal point here, instead of writing 980, I can write it as 9.8 into 10 raised to 2. What am I doing? I'm just putting a decimal point here. Why? I'll explain you now. So 980, I can write it as 9.8 into 10 raised to 2 into 10 raised to minus 5 Newton, right? So that is equal to 9.8 into 10 raised to minus 3 Newton. Is it clear? So 1 gf is nothing but 9.8 into 10 raised to minus 3 Newton. Now, in order to convert gf into dyne, I multiplied it with 980. In order to convert Newton into kilogram force, try and understand this, don't get confused. To convert 1 kgf into Newton, 1 kilogram force into Newton, I'll have to multiply it with the acceleration due to gravity. And in SI system, an acceleration due to gravity is 9.8 meters per second square. So I'll have to multiply this one by 9.8 to convert kilogram force into Newton. If I want to convert Newton into kilogram force, I'll divide it by what? By 9.8. So let me convert this Newton into kgf. How do I do that? How do I do that? I divide it by 9.8. So 9.8 into 10 raised to minus 3 divided by 9.8. So what do I get? 10 raised to minus 3 kgf. Now look at this. 1 gram is equal to 10 raised to minus 3 kgf, which I had already taken. You can directly take it here, how they are related to each other. Either do it this way or you can understand it this way. Clear? Let's go to the next question. Define weight. What is the weight of mass of 2 grams in SI system? Okay, the second part we'll do later. Let's define weight first. If I'm standing on the ground here, what is my weight? The force with which I am pushing the earth, right? That means why am I pushing the earth? Because the earth is pulling me towards it. So what is my weight? The gravitational force acting on me, that is pulling me towards the earth. So what is weight? Weight is the gravitational force acting on a body that attracts the body towards earth. Clear the definition? The gravitational force acting on a body that attracts the body towards the earth. Clear? Let's go to the second part. What is the weight of mass 2 grams in SI system? Now, mass is 2 grams. First of all, I'll have to convert this in SI system. Mass, that is grams, into kilograms, that is 2 into 10 raised to minus 3. 1 kilogram is 1000 grams, right? So grams to convert into kilogram divided by 1000. So if I am dividing it by 1000, see, if I am dividing anything by 1000, that means what am I doing? I am dividing by 10 to the power 3, right? 10 to the power 3. If I bring this 3 up by the rule of exponent, I am multiplying it with the power 10 to the power minus 3. So this is how I convert mass into SI system, kilogram. I've got the mass. Now what are they asking me? What is the weight? So what is the weight? Weight is the gravitational force acting. So weight, let me do weight with some other color. Weight is equal to mass into acceleration due to gravity. For calculation purpose, let's take it as 10 acceleration due to gravity. So I'll have this 2 into 10 to the power minus 3 multiplied by 10. So what would be the answer? The weight would be 2 10 to the power minus 2, right? Applying the laws of exponents, I'll get minus 3 plus 1 minus 2. So minus 2 what? Newton, right? 2 into 10 to the power minus 2. Or I can also write this as 2 by 100. That is 0.02 Newton. Clear? Either I can keep it like this or like this. That is the weight of 2 grams in SI system. Okay? Let's see the next question. Write the nature of the force involved in the following cases. A cylinder rolling on the ground. Now, let us imagine a cylinder that's rolling on the ground. That means it is moving forward, right? Now, what are the forces acting on it? First of all, I might have pushed it. That is why it is rolling on the ground. So, this is muscular force, right? Muscular force. And definitely I might have gone to it, touched it and pushed it. So this is a contact force. Let me write capital C for contact force. Okay. Then let us do it with purple. The weight The earth that is pulling it. Now we know earth, to pull it, it need not be in contact, right? So this is a non-contact force. What is that? Gravitational force. Gravitational force. And that is a non-contact. Let me write it as NC, non-contact force acting on it. Okay, so one downwards, another I have pushed it, so it's rolling in this direction. Then let me go to the third one. There's one more force acting, and we know whenever there is motion, there will be a force provided by this earth which is opposing it. By this surface, it will be opposing that motion, and that force is called as frictional force. And that frictional force is also a contact force. Clear? So that's a contact force that is acting on his body. Now, let us see second condition. What does the second condition say? A stone projected in vertical direction. A stone projected in vertical, either upward or downward direction. Let me take both the cases. A stone is projected vertically upward. Clear? It is pushed up. Now, when it's pushed up, who will push it? I will push it, or some machine or something else. That means there is a muscular force, right? Let me write is only the short form. And muscular force is a contact force, right? So muscular force, which is a contact force that is acting on it. Next, as it is going up, there will be one more force acting on it. Let me take the same color. Which is that force? That's the gravitational force. And gravitational force is a non-contact force. Clear? Earth doesn't require the contact to pull it. If it is moving upward, there is one more force acting. I've selected a black color. So what will be that force? Frictional force. Right? Frictional force. And that will be a contact. Who will provide that friction? The air. Right? Because as the stone is moving up, the air will provide the friction and oppose its motion. That's the frictional force. Just in case, if the stone is dropped, right? I'm just holding this marker and just dropping it. I'm not applying force, right? Because the earth is going to pull it. So then what forces are acting? Suppose the stone is moving downward. If I push it, then a muscular force will be involved. So I'll have to ask that question whether I have pushed that stone or I've just released that stone, right? So when what are the forces acting then? The force acting would be the gravitational force, which is pulling it down, and again it will be a non-contact. Frictional force, which the air will be provided as the body is moving downwards. So clear in both these cases. So whenever you have been asked what is the nature of the force that is acting, just try to imagine that picture in your mind, so that you get a clear idea what are forces would be existing there, and then answer it, and then find out whether they are contact or non-contact, and accordingly you can answer them. It's very simple to do it. Okay, let's see the next question. Does any body exist without any force acting on it? Now, let us try to imagine this pen. I'm holding it in my hand. Is there any force acting on it? Of course, gravitational force, right? Is there a wind moving around? Right? This wind, is it pushing this body? I don't see the motion. Right? So I just told you, you'll have to imagine that thing, picture that entire thing, and then find out your own reasons for it, okay, whether this exists or not. Does any body exist without any force? My answer is directly no. There will be some force acting on it. Then why it is not in motion? Right? That force will not be sufficient to pull that body towards it. Right? For example, now when I am leaving this body, the earth will pull it down. When it is lying down on the earth, so is there any force? If there is air moving around, it will exert a force. Then what is happening? Why the body not moving? Because there is a frictional force acting in opposite direction, which is not allowing the body to move. Right? The body, when I see benches, decks, everything is on earth and it is not moving, that doesn't mean it is not experiencing any force. But what is happening? The force applied and the frictional force that exists, they cancel out, the net force is 0. That is why it is not moving. I hope this point is very clear to you. Body on a body, net force would be 0, can be 0, right? But no force acting on it, that is not possible. If you take it to the space where there is no air, gravitational force will be acting. Some other heavenly body may be pulling it towards itself. Sun will be pulling it towards itself, right? So there will be some force acting on a body. If it is not moving, that means the net force can be 0. Multiple forces that are acting, the total force, the net force becomes 0. They are not asking me net force, they are asking me, can it exist without any force? So my answer is no. And how do you explain it? I hope you have understood that. Okay, let's see the next question. Mention the magnitude and the direction of the net force for each of the following cases. Take acceleration due to gravity as 10 meters per second square. So I have to mention the magnitude as well as direction of the net force. Now here there are two forces acting. One is 2 kg weight and other is 2 into 10 raised to 6 dyne, right? Now both these are in different units. One is in kgf or kg weight unit and other is in dyne. So let me convert this into Newton, right? How do I convert kg weight into Newton? Multiply it with the acceleration due to gravity. So I get 2 into 10, that is 20 Newton. The force acting in this direction is 20 Newton. Let me convert this, for that I'll take another color. Let me convert this into Newton. How do I convert dynes into Newton? Multiply it with 10 raised to minus 5. Remember all these factors. So 2 into 10 raised to 6 into 10 raised to minus 5 Newton. So let us see how much is it. Using the laws of exponents, 6 minus 5 would be 1. So 2 into 10 raised to 1 Newton. That is nothing but 20 Newton. So what is the force acting in, so let's say in my right, towards my right is 20 Newton. What is the force acting towards my left is 20 Newton. So the net force will be 0. Net force will be 0 and there will be no direction. Since there is no force, there will be no direction. Let's see the second case. Now I'll use some other color for that. Now here there is a mass of 10 kg, right? And it is at this height. That means earth will pull it, right? How do I find its force? So the force acting here, I can take it as weight. Weight is nothing but m into g. So what is m? M is 10, g is 10. So I get it as 100 Newton. So what is the force that is acting? 100 Newton. And which direction? Downwards. Clear? But now when it will start moving towards downward direction, what would happen? There will be friction, right? Air will be providing friction. So what I'll say, I'll just say that in case there is no friction around it, the force will be 100 Newton in downward direction. So just I'll mention that if there is no friction, then this would be the case, because I cannot find friction, right? Because no condition is given to me. So I'll say in the absence of friction, the force acting is 100 Newton in the downward direction. Clear? Let's see the next question.